Hey all, this is Math 116, section 1.5, and this is about solving systems of equations. So we kind of have three possible outcomes for systems, and this is the two-dimensional version. We'll look at three-dimensional problems, but it's easier to follow the geometry with 2 dimensions. So the first and kind of the most common thing is that there's an answer, and when that happens, there's one solution, and it's going to be the point of intersection of these two lines, so in this case 2, 3. The other two things that can happen are, one, the lines are actually parallel to each other, so they're never going to cross, so that's a no solution. We'll have the same thing in 3 dimensions. And then the third thing is they actually gave you the same line, so they gave you one equation, and then they gave you another equation, but it was just the exact same thing, maybe disguised. And for that we get an infinite number of solutions, which isn't all real. It's all the values that make up this line, which isn't all real numbers, so a little distinction there. For the no solutions, we're going to get some sort of false statement when we go to solve it, so 0 equals a number that's not 0. For the infinite, we'll get 0 equals 0, or like 10 equals 10. We'll get something true, but all the variables will drop out in either case for these. And then we have a couple of different methods for solving. We're mostly going to use elimination, but I'll do kind of one example of substitution here. There's places where substitution is handy. This one I probably really do by elimination, but we'll show it as a substitution. So for substitution, what we do is we isolate one of these variables. So I'm going to bring this y over to this side and the 2 over to this side. So that would make 2x minus the 2, add the y over equals y. So what I've done is I've solved for one of the variables so that I can substitute that into the second equation for the y. So since y equals 2x minus 2, I can put that right here. That gets me one equation and one unknown. So that's substitution method. So this will look like 3x plus 4 times that stuff equals 6. And now I can just solve this out and get x. Once I have that, I can plug it back in and get y. So here we'll get 8 minus 8 equals 6. 3 and 8 is 11x minus 8 equals 6. Add the 8 over, not a nice answer. And then divide out the 11. So x is sort of this unfortunate 14 elevenths, but it's just kind of what we got. And now plug this in here and then get y. So this is called back solving. So 2 times 14 elevenths minus 2 equals y. So 2 times 14, that would be 28 elevenths minus 2. And since this is elevenths, I'll do 11 over 11 right here, equals y. And then 28 over 11 minus 22 over 11 equals y, so that is 6 elevenths. So our solution set is 14 elevenths, comma, 6 elevenths. So that's the ordered pair where these two lines would cross. Okay, so this next one we're solving by elimination or any convenient method, which is generally going to be elimination. So the idea with elimination, and this is one you probably hopefully remember from a previous class, is we want to multiply one or both of these equations by some constant so that we get the same coefficient but with opposite signs, so that when we add them together they cancel out. And I'm going to just kind of, to make this easier to follow, I'm going to call this one equation 1, this one equation 2, and I'm going to go negative 2 times equation 1, and then I'm going to add to that 3 times equation 2. And the reason I'm doing that, so negative 2 times equation 1 is going to get me a negative 6 right here. 3 times equation 2 is going to give me a 6 right there. So I'll have minus 6 plus 6, and then I can add those and they cancel. And what I do to this, I have to do to everything. So we'll just run the 2 across. So it's going to be negative 6x, negative 2 times 4, so negative 8y, and negative 2 times 1. And then same thing here, but with a 3. So 3 times 2 is 6x. That's what we wanted to happen. 3 times 3, negative 9y. 3 times 12 would be 36. Those cancel. This makes negative 17y equals 34. And then divide this negative 17 over. And we get that y equals negative 2. So once I have that, I can plug it back into either of these equations. I'll just arbitrarily pick the first one. So 3x plus 4 times negative 2 equals 1. And then we'll just do our back solve. So 3x minus 8 equals 1. Add the 8 over. 3x equals 9, and x equals 3. So this one comes out 3, negative 2. This one with the fractions, so definitely what we want to do is not have fractions. So I'm going to multiply this one by 2, and I'm going to multiply this one by 3 to clear the fractions. And that will just make it a little bit easier to look at. So here we'll go, this will make 2x, 2 over 2 would cancel, so minus y, 2 times 1 would be 2. And here the 3's cancel, 2x, 3's cancel, minus y, 3 times 1 makes 3. So maybe you can already see that something funky is going to happen here because these two are exactly the same except for the equal side. So what I'll do is I'll just bring down this first one. I'm going to multiply the second one by a negative 1 to get opposite signs. So negative 2x minus and minus make plus y, and then minus times 3 would make negative 3. And again, that's just for the convenience of adding because we're better at adding than subtracting. So those cancel, leaving me nothing on this side. And on this side I get negative 1. And so this would be no solution because we got this false statement. If we got 0 equals 0, then it would be dependent. So these are the two I'd have you try. So for this first one, it looks like if I did positive 3, I'd have negative 3x, positive 3x. So that seems like a good idea. So I'll do a 3 across this one, 3 times x, and then 3 times 3 for 9, 3 times 12 for 36. And you can kind of see what's happening. Everything is dropping out, and we're getting 0 equals 0. So that's an example of dependent, which is the infinite solution version. And then for this one, let's do, I could either make these 12 or these 6. So I think I'll make these 6 just because a little bit smaller numbers. So I'm going to do this by 2, and I'm going to do this by 3, and I already have opposite signs. So 2 times negative 4, negative 8, plus 2 times 3 is 6y, equals negative 10, and then do the same idea here with the 3. So 9x plus 6y, minus 6y, equals 3 times 4, 12. And then that's going to just leave an x, those drop out, and that equals 2. And now I can just drop it back into either of those original and solve. I think I'll pick the second one, slightly smaller numbers, I don't know, doesn't matter which one you pick. So 3 times 2 minus 2y equals 4, so this would be 6. I'll bring it over here. Negative 2y equals negative 2, and y equals 1. So our solution set is 2 and 1. Okay, then we have 3 equations and 3 unknowns, so this is a little bit harder. With this, what we have to do is we have these equations 1, 2, and 3. And so I'm going to put 2 equations together, eliminate a variable, and then I'm going to put 2 different equations together and eliminate the same variable. And what that's going to do is get us to 2 equations and 2 unknowns, and then it's right back to the problem that we just did. So in this case, I could either try to eliminate x, but I'd have to do something with the 6, which is kind of a big number. Y looks pretty good, and z wouldn't be too bad. So I think I'll do y, but I could pick any variable. I just have to make sure I eliminate it twice with 2 different pair. So for the first round, I'm going to go equation 1 and then I'm going to use, I like equation 3 because it has easy coefficients, so I'm going to go 2 times equation 3. And that's going to give me a minus 2y plus 2y. So 2x plus 2y plus 2z equals negative 8. And that's going to make 3x, the y's drop out, which was the plan. 2 and 2 makes 4, z makes negative 8. And for convenience, I'm going to call that one equation 4, just to give it something to reference as. And now I'm going to do equation 2, and I'm going to put that with 3. 6x. And I'm going to do 3 by a negative, because I have a plus y, so I'm going to make it a minus y. And minus and minus will make that a plus 4. So here I get 5x, y's drop out as planned, 3 minus 1 would leave me 2z equals 10. And again, for convenience, I'm going to name that one equation 5. And so now I have this 4 and 5 that are both in terms of x and z, and that's really important. That's why you have to eliminate the same one twice so that they match. And now I can just eliminate either x or z from these two like we just did in the last few problems, and then that gets me my first answer, then I can do the back solve again. So I think I will do equation 4, 3x plus 4z equals negative 8, and then I'm going to go negative 2 to equation 5. And that'll get me a minus 4z here. So negative 10x and minus 4z equals negative 2 times 10 would be negative 20. So negative 7x equals, that drops out, negative 28, and x equals 4. Once I have my first answer, now I can come back to either of these equation 4 or 5. So I'll go ahead and pick 5, again, arbitrary. I could put it in 4, I get the same answer. So 5 times 4 plus 2z makes 10. So that's 20 subtracted over. 2z equals negative 10. And then divide, and z equals negative 5. So now I have x and I have z. So I can come back to any of the originals and get y. 3 definitely looks the easiest, so I'm going there. So x is 4, y I don't know. Z is negative 5, and that makes negative 4. So 4 minus 5 is 1, negative 4, add the 1 over, and y is negative 3. So my solution set would be 4, negative 3, negative 5. Okay, and this one I would have you guys try. So for this one, I would pick either y or z. They're both pretty friendly. I'm going to pick z because it does kind of a weird thing, so I just want to show you that weird thing in case you run into it. But y would also be a totally good choice. So I'm going to go 1 plus 3, and that's going to eliminate plus z minus z. And then so this will make 4x plus 3y, z's drop out, equals 8. So that would be my equation 4. And then I'll do the same thing. I'll do a negative 2 to equation 1, and then I'm going to add that to equation 2 and eliminate z again. So negative 2 times equation 1, and then add to that equation 2. So that'll look like negative 2x minus 4y minus 2z makes negative 6. And then let's copy this down. And so what happens is more than kind of we planned on, and sometimes this will happen. So minus 2x plus 2x, those are gone. Minus 4 minus another 1 makes minus 5y. Minus 2 plus 2, those are gone. Minus 6 plus 6, those are gone. So that's not a no solution. It's negative 5y equals 0. So when something equals 0 like that, the variable's still there, so it just means that y is 0, is what that tells us. So I don't have to solve for that next solve because I already happened to pick up an answer here. Now I can just plug that back into equation 4. 4x plus 3 times 0 equals 8. So 4x equals 8, so x is 2. So it's actually nice when that happens because it's a little less work, but sometimes it just kind of throws people. And then I'll plug this back into an equation 1. So x is 2, 2 times y, 2 times 0 plus z makes 3. So that is 2 plus z makes 3, so z equals 1. So solution set is 2, 0, and 1. Okay, and then these last two are the application problems, and they are a little bit difficult. So the first one goes, one safe investment pays 10% per year, a more risky investment pays 18% per year. A woman who has $120,000 to invest would like to have an income of $16,360 per year from her investments. How much should she invest in each rate? So we saw a problem kind of like this back in the one variable section. And with that, what we ended up doing was sort of a substitution method and writing the whole thing at once. This time I'm going to write it using two different variables. So I'm going to let x be the 10% amount, and I'm going to let y be the 18% amount, since now we're solving systems of equations. So that would mean x plus y, the amount she has at 10% and the amount she has at 18% is going to equal the total amount of money she has, $120,000. And then we're going to say 10% of this is interest, 18% of that one's interest. So 0.10x plus 0.18y. So those two interest payments together are supposed to equal the 16,000 number. And then there's our equations. Whenever I have something like that, I just take the smaller of the two unpleasant numbers, make it negative, and then I'll just multiply this easy equation by it, and then, oops, let me write it right, 0.10. So we multiply this by this number, negative, and then add them together. So that'll be negative 0.10x, and then 10% of that negative will be 12,000. And then their second equation, and I'll add those together. This drops out. This becomes 18 minus 10, so that would be 0.08y. And then negative 12 plus the 16 is 4550. And then just dividing this over, and I get y equals 54,500. And since we know she has a total of 120,000, we can just say x plus that 54,500 has to equal 120. And then subtracting this over, we get the amount at x, and that's 65,500. Okay, so this last one has lots and lots of words. So bacteria of species A and species B are kept in a single test tube where they're fed two nutrients. Each day the test tube is supplied with this many of the first nutrients, that many of the second nutrients. Each bacterium A requires 2 of the first unit and 3 of the second. Bacterium B requires 1 unit of the first nutrient, 4 units of the second. What population of each species can coexist in the test tube so that all the nutrients are consumed each day? So try to figure out how many of each kind of bug we can throw in there so that they eat all the food provided. So there's two things in this that kind of feel like totals to me. And when you can find the totals, that tells you what kind of equations you're writing. So each day the test tube is supplied with 10,600 of the first nutrient and 19,000 yada 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 of the second nutrient. So that tells us that we're going to write equations for nutrients. So I'm going to have something equals, I'm going to have however much of nutrient A is getting used by each species equals 10,600. So that's my first nutrient. And then this 19,650 is the second nutrient. So A and B are going to consume some amount of this, A and B are going to consume some amount of that. So then going back to the rest of the reading, we have for the first nutrient, A requires 2 units of the first one, and B requires 1 unit of the first one. So 2 units for each A plus 1 unit for each B. And that has to equal the total number of the first kind of nutrient. And then for the second nutrient, A consumes 3 of the second and B consumes 4 of the second. So for every A, they're going to eat 3 units of the nutrient, and for every B, they're going to eat 4 units of the nutrient. And then that gives us our 2 equations. So I just went with multiplying this top one by a -4, and then that's going to have the B's drop out. So that will make -8A, minus 4B, and then negative 4 times that made negative 4240, and adding the second equation to it. And so on this side I got negative 5a, those cancel, and combining those I get negative 22,750, and then divide the negative 5 over. Negative over negative would be positive, and that came out to 4,550. And then I can just plug that back into either equation. This one looks easier, so I'll do that. 2 times 4550 plus b equals 10,600. So I just multiplied this out and subtracted over and got b to be 1,500.